As a biologist, what I'll be talking about is focused on biology, but it should be applicable to all the other sciences too. After years of schooling, you're used to being told what to learn, and by this stage you'll be aware that quite a bit of that information isn't quite right. What you came across at GCSE was greatly simplified. You get a different story at A-level, but that's also an approximation to the truth. When you go to university, you'll find that the point of the university education is not to make you learn loads more facts, but really to teach you to think and to make use of the information, to put it together, to sift through the sources and to find your own interpretations. A lot of the first year is setting the groundwork for that thinking, making sure everyone has the basics, no matter what their educational background. So there can be quite a lot of learning of content at that point. But this time we aren't reducing it to inaccurate simplifications. If it is simplified, we'll tell you, and we'll explain how and why that's appropriate for now. However, at university a very large part of the information is going to be stuff that you find for yourselves. This does create some problems, because there's a vast amount of information out there, and you're going to have to learn to find the right information and decide what is important. Particularly in the sciences, there's far too much information for anyone to cope with. Whilst you do need a broad base for understanding your particular interests, it's impossible to keep up with the scientific advances in all fields. And that means that no one can hope to understand everything that they come across. Here I'm going to give you a quick overview of how to use information in a sensible way. Information at school always comes packaged into textbooks, and usually the textbook that is designed for the specific exam-based curriculum that you're sitting. University level textbooks are different. They aren't designed for any particular curriculum because each university has its own course content, structure and style. Textbooks work well for some courses. In biology, the vast amount of content in cell biology and physiology probably requires some form of general textbook. And there's some scope for some very specialised textbooks, although these tend to be out of date almost as soon as they're published. University, department and college libraries have all the books you would need as an undergraduate, whether these are textbooks, specialised books or historically important works. And they used to have shelves and shelves of journals. But however good the libraries are, they contain a minute fraction of the information that is available online. With that vast amount of information at your fingertips, there is inevitably both a lot of great material and also a lot of rubbish. Added to that, much of it is going to be extremely specialist and understandable only to specialists. So when approaching the scientific literature, you do need to know what to look for. When you look at a scientific paper, you should find that the basic structure is very familiar. The reason you've spent years writing up practicals in a very formulaic style, introduction, methods, results, discussion, is that that is the standard structure of the paper. The introduction introduces the issues to be investigated. The methods are there so you can see what was done and judge whether it was reliable, or repeat it yourself if you wish to check something. Then there are the all-important results. And finally, the discussion that interprets everything. In the second session, I'll come back to this when we talk about experimental design and hypothesis testing. One part of the paper that's probably less familiar is the abstract. This is a short summary right at the start. That's the really useful bit, as it's the part that everybody reads before deciding whether it's worth reading the rest of the paper. So most of the time you'll read the abstract, decide that despite the title it doesn't really deal with the topic you wanted, or doesn't add anything more than what you've already found. However, if the abstract does seem to fit what you want, then read further. Some abstracts can be really clear and helpful, others immediately indicate that you need specialist knowledge for it to be worth reading any further. This distinction between clear and excessively specialist is also apparent in the main part of the papers themselves. So if you start reading a paper and quickly feel lost, Don't worry, if you aren't a specialist, you aren't going to understand all of it. On the other hand, there are also plenty of extremely good review articles which are published specifically for a broader audience. These also tend to be much better written anyway. One thing that's worth paying attention to is the quality of the figures. These are invaluable. They give a visual impression of the results and sometimes the methods, making it easier to get an impression of what the data means from a graph than from a statistical probability value. However, in some journals there are restrictions on the number of figures that can be used, so authors may cram as much information into a single hopelessly confusing figure. So again, if it's good, that's great. If you don't understand it, that's a failure of communication by the authors or by the journal. An interesting, relatively recent development is the graphical abstract. Some journals are using these to take advantage of that effective visual conveyance of information. Unfortunately, because they are new, not many people have worked out how to use them effectively. What's this one about? Who would win a fight, a snake or a shark? No, apparently it's an approach to electronic structure in quantum mechanics that has an acronym that sounds a bit like Shark Cobra, apparently. And this one turns out to be about a dye that can be used to study live mitochondria. So they're usually not very useful, but in the future you might find that they become a good way of quickly finding out if this paper is worth a proper read. Recently, there has been a faster means of publicising research findings, the preprint. Preprints are publicly available drafts that have not yet been submitted to a journal or reviewed. The idea is that the draft can be improved before submission, so it should make for better papers and for faster review. They can be very useful sources of information, but you should be aware that they haven't yet been fully reviewed and could change dramatically by the time they're published. Publication is changing quite rapidly at the moment. I'll end this with a very simple example of something I published recently. This is a very short publication, basically a note, reporting an observation that was backed up with a video. The video is included as online supplementary material, so the reader can easily follow a link to it. The text for this paper is very simple, because the video evidence speaks for itself. All that was needed was some context and a discussion. So with this we have the observation of a giant tortoise hunting down and eating a bird. It's a very simple observation, startling, rather disturbing, but that's all it is. But it's worth recording. The start of the paper gives the context, what would be the introduction in a longer paper, summarising where and when the video was recorded. The interpretation is what would usually be called the discussion or conclusion. Here we speculate as to what this single observation might mean. I'll come back to this publication in the next session when we look at how an observation leads to a hypothesis and from there to a research project.